All right. So, what types of foods or drinks do you guys see advertised the most often? Foods or drinks often advertised. Pizza.
Healthy products.
Health foods.
Like healthy alternatives.
Okay. I might have spelled that wrong. All right. Anybody else? Pepsi, Coke, soft drinks, chips, snack foods, Cheez-Its, yeah. All right. What about not often, rarely?
Yogurt.
What? Saltine crackers. Okay.
Yogurt.
Do you guys ever see like advertisements for like fruits and vegetables? Yeah, I think it does. What about milk or bread or quit just shouting out words?
No, like actually.
You rarely see pudding advertised. Okay, why do you think these ones we wrote in purple, why do you think they're not advertised very often? They're essentials. And you're going to buy them, maybe not saltines, but you're going to buy them regardless of how much advertising there is. And there's a lot less brands of, if we take off the saltines, there's a lot less brands of those things. So there's not really a purpose for advertising them. Okay, so let's talk about this formula and soft drink situations. I'm going to skip A. On B, so which customer base, formula or soft drinks, is more swayed by an increase in price? Yeah. How do you know? Yeah, it drops faster. All right. So one thing that you might want to consider, like with formula, it's really easy to switch a soft drink. Like if one brand costs more than the other, you can just buy another brand. Typically, mothers or parents don't do that with baby formula just because it affects their digestion and stuff. So they're less likely to switch brands even if the price increases. And they're definitely going to keep buying it because they want their baby to eat. All right, and then this was just filling in, just multiplying and filling in. So I'm going to skip that also because I think you guys all did that fine. Do you think it's a good idea for food companies to always charge more? No. Why not? Okay, sometimes it's ethically wrong. And mainly because they'll lose customers. So if you charge too much, people don't buy your product. They'll choose something else. I think something similar is happening like with the fair right now because they are charging so much to get in, less people are going, so they're probably going to bring in less money in general. Okay, so let's talk about this one. This graph is different. So this one is not. Hey Xavier, why don't you go back to your regular? All right, this is not price customers. This is price revenue. That confused some people in my last class. All right. And so this first one, an intern suggests selling formula for $20. Is this the best price? No. What about 80?
No.
What is the best price? Around 60. Because that's going to be the peak. All right. At what prices is the company not making any money? 112? I said 117, but 112, 117, 115, that's fine. Why are they not making any money if they charge $0? It's none. So if you don't charge anything, you're definitely not going to make any money. What about 117?
Because it'll be too high and we're vice versa.
Good. All right, so a good part of our lesson is going to be on interpreting graphs. This is what you guys kind of just did. The other part is going to be on average rate of change, which is what they asked you to do on number 7. So between p equals 0 and 60, how much revenue change on average, or how much does the revenue change on average? So between 0 and 60, how much did it change total, do you think? From here to here. Yeah, I'm going to say a little bit more than 24. So we're going to say 2,500. And how much price change is that over that period? 60. And so that's an average rate of change of $41.67 million. So what that means is between charging $0 and $60, the revenue change, or let's say increases. $41.67 million per change in price. All right, and then 8 is just a question to think about, like when or why might companies use factors besides revenue to determine their prices? It kind of goes back to where we were talking about the baby formula. It's a kind of an ethical situation. You don't want to charge too much where someone can't feed their baby, or supply and demand. All right, I'm going to hand you guys the notes. Because I knew today was going to be a little bit longer, I have filled in some of the words for you, so you don't have to write as many words. Okay, so one main thing we're going to do today is find where functions are increasing and where they're decreasing. So a function is increasing on an interval from A to B. These are both x's, just keep that in mind. If the y values are getting bigger from left to right, that's not very professionally worded, but that's what it means. And a function is decreasing on an interval from A to B. Those are both x's. If the y values are getting smaller from left to right. So I'm going to just draw a little graph. So increasing, like as you go from left to right, it should get taller and taller and taller. And then for decreasing, as you go from left to right, it's getting shorter. Or falling, rising and falling. All right, and then one other thing we're going to find today on graphs are the relative maximum and relative minimum values. And it might be a little different from what you did in Algebra 2, but when we give the relative maxima and minima in pre-calculus, we're only going to give the y values. So it's going to be where the y values of the function are at highs or lows, or the top of the mountains, or the bottom of the valleys, basically. Right. And then probably won't get to it until tomorrow, but the average rate of change is just another way of saying the slope. So we found slope quite a bit in here. When you were finding a slope, you were also finding the average rate of change. So what formula did you guys use to do that? Yeah, rise over run, change in y over change in x. I think someone said y2 minus y1 over x2 minus x1. I'm going to show you one more way to write it, and this is a way we're going to try to start doing it. It's a little more sophisticated, I guess. And it's if you have a function, if you want to find the average rate of change, it's going to be f of b minus f of a over b minus a. All of those, you're finding the same thing. And if you want to interpret it, which we may do tomorrow, you can just fill in these blanks if you want to. So you would say on average, and then whatever the y variable is. It might be revenue, it might be number of customers, it might be distance. And it's going to either increase or decreasing depending on if it's positive or negative by, and then whatever the average rate of change is. I did ROC for rate of change just to save time. And then it's going to be per unit of whatever the X unit is, which it might be minutes or it might be dollars. It could be lots of different things. All right, so let's look at this first graph. And what we're going to give are the intervals of increasing, decreasing, and constant. What? You don't have to connect them. Don't connect them. This is a piecewise function. All right, so the place where I think it's increasing is where there's a positive slope, which is going to be this section right here. It's going to keep on going to the right. Now try your best to remember that when you're giving intervals of increasing, decreasing, and constant, you're only using x values. So what x value does this graph start increasing?
4.
Yes. So we're going to do interval notation starting with 4 until infinity. Forever to the right is infinity. Nice job. All right, so decreasing. Let's see if I can find purple. There we go. I would say this section is where the graph is decreasing because from left to right, you're falling. It's a little bit more difficult to do this interval notation. So don't forget, the number on the left is the smallest number where the function is decreasing. On the right is the biggest. So what is the smallest number where this function is decreasing? Nice job. As far as you can go to the left is negative infinity. Where does it stop? Nice, nice, nice. All right, and then I didn't draw a constant, but I think you guys know this, right? A function is constant whenever it's horizontal. So that would be the section right here. And that's going to be from 0 to 4. Now, one thing I know your Algebra 2 teachers talked about was only use x's on these intervals. So it sounds like you guys are doing okay. So they got through to you. Okay, so for number 2, this is a contextual situation where Easton walks from his house to the bank, then to the grocery store before returning home. Okay, so let's just look at this. He starts off and he is walking away from his house. What's happening right here at this flat spot?
He stops.
Stops. Where does he stop first? Yes. Okay, then he keeps walking. And what about the second flat spot?
To the grocery store.
Good job. And then he goes back home. So how long does this trip take total? Would you guess?
67 seconds.
Not 67 seconds. 75 minutes from when he leaves his house at time 0 to when he gets back to his house down here when time is 75. All right, and then how many minutes was Easton at the grocery store? So let's just see.
About 10 minutes.
I think it's more than that.
Oh, the grocery store? Looking at the bank.
You are looking at the bank. Yeah, that's going to be 15 minutes from minute 45 to minute 55. All right, on what time intervals or interval is D decreasing? From what time to what time? 55 to 75. How do you know? Or what does this mean in the context of the problem? What was he doing between walking home? I'm a bit walking toward his house. All right, and then at what time or times is Easton exactly 1 mile away? We're going to have to estimate because they don't look like they're at an exact line.
13 minutes
Okay,
and 67 minutes.
that's exactly what I wrote earlier. Actually, I wrote 68, but it's fine. All right, any questions on that? Okay, the next graph doesn't have a contextual situation with it. It's just interpreting the graph, so it's going to go pretty fast, I think. And so 3a says to find all the values where g of x is 0. Those are going to be the x-intercepts. All right, so that's going to be when x is -3, -1, and 2. All right, B asks us to estimate the relative minimums of G. This one actually has 2 relative minimums. So anytime you have a valley, then it's going to be a relative minimum. So one of them looks like about -35, and the other one is definitely 0. I didn't. I used Y's on both of those. Oh, are you talking about the x-intercepts? You only use x's on the intervals of decreasing and increasing. So x-intercepts are definitely going to be x's. All right, and then how many relative maximums is there? Just one top of a hill right there, and I'd say that's about 32. Actually, we're going to go ahead and finish this today. All right, on this next one, I'm going to show you how to do something in your calculator that you may have never done before. All right, so for number 4, we have this g of x, and we want to find the average rate of change on the interval from 1 to 6. So I am going to use this formula we wrote right here. So I'm going to just start off. A is going to be 1, and B is going to be 6. So our function is called g. So we're going to have g of 6 minus g of 1 over 6 minus 1. Now you can definitely just plug those in for x, like take 6, plug it in for all those x's, take 1 and plug it in for those x's, and it's going to work. But I'm going to show you guys a shortcut. I think you're going to like it. Okay, the first thing you're going to do, if you guys want to do this with me, is go ahead and plug that g into y equals. and then just go back to the regular screen. Right, do you remember how to get a little fraction guy? Alpha y equals, so we get the little fraction guy. All right, so where this says g of 6, we're going to actually just do that in the calculator. So we just put that into y1. Whenever you want to get the y variables, I'm going to write this down just a second. You do alpha trace. So alpha trace takes you to the y variables. And so we'll just do y1, and then just put the 6 in parentheses. So that is going to do g of 6. That's going to take 6 and put it into what you put in for y1. And then we can do minus, and do that again, alpha trace, and then put in 1. And then in the denominator, you can do 6 minus 1, or you can just do 5, whatever you want to do. There it is. Magic. All right, so anytime you want to evaluate a function, like if I just wanted to find what g of 7 was, you can do that. So that's the only time I think in your calculator that the parentheses don't mean multiply, the parentheses mean put it into the function. So that's just going to be 2. All right, let me jot down those steps to get y1. So you're going to hit, I have to look at it to remember. You're going to hit alpha trace. All right, and that just gives you the y variable. And it'll save you some time, especially if you're doing a bunch of them with the same function. All right, and then for number 5, we're going to find the average rate of change using the table. So this function h gives you the temperature of a pot of tea after so many minutes. So how fast is the tea cooling on average over the 10-minute interval? Or you could say over the interval from 0 to 10. So we're going to do h of 10 minus h of 0 over 10 minus 0. Now this one, we don't have like a trick in our calculator. We just have to use the points from the table. So what is h of 10? You're using the table 43. What about h of 0? 66. So we're just looking at those 2 points. And then that is a decimal. Negative 2.3. All right, any questions on that? That's something we do a lot in calculus, is do the average rate of change using the table. We do it a ton. Okay. You could get negative 23 over 10 also. All right, no, you're fine. Okay, and then this last one, everybody's graph can definitely look different on this last one, just depending if you make yours curvy or straight or how high or low it is. But for our graph from negative 5 to 0, we want to be decreasing. So I'm just going to do it in line like that. From where x is negative 5 to where x is 0, I have a negative slope. All right, and then the next little section from 0 to 2, I want to be increasing. So I'm going to just do it like that. And then the last section from everything greater than 2, I want to have a constant. Now these sections didn't even have to touch each other. I don't really know why I drew it that way. It could look something similar to what we had on number 1, where it's just segments. But that is an example of something you can do. All right, what questions do you guys have on increasing, decreasing, average rates of change? All right, we'll practice it tomorrow.